Hey guys, so I actually want to just take a few minutes to talk through our summative a little bit, just to make sure that everybody is on the same page, and that way we don't have to rely on what I just said in class. You actually have this video to go back through in case you forget anything or need a little bit of extra help with it. So, for my groups that I saw today, I mentioned about how that virtual plant lab, that plant growth lab, I actually changed back to a formative. And we talked about some of the inconsistencies that I saw in the answers. If I'm seeing you on Tuesday, we'll talk about that then. So you probably noticed in the grade book that your plant growth lab is a formative. Okay, instead, we have 3A here as our summative. Okay, so we have both a section dedicated to 3A as a summative and a section for modeling for 2B as a summative. So let's talk a little bit about these. So with our first one, we have this investigation summative for 3A. And here, we have some background info and a video about bromothiamyl blue. Now, I'm not going to play this video in this video, but make sure you do so. It's only like 24 seconds, I believe. So, our background info talks about bromothiamyl blue as an indicator. And we've talked about chemical indicators before in our food lab. So just like with our indicators in our food lab, bromothiamyl blue is going to show us the presence of something. It's going to show us that something is present. Bromothiamyl blue is actually going to show us that carbon dioxide, or CO2, is present. So we have bromothiamyl blue starting off with a blue color. And as we can see in our test tubes down here, the majority of them are blue. We actually have our original setups for two experiments here. So bromothiamyl blue is blue in color. When carbon dioxide is added, it actually turns to green or a yellow color. The more carbon dioxide that is present, the more yellow it will be. So if there's a little bit of carbon dioxide, it'll turn like a greenish. If there's a lot of carbon dioxide, it will turn yellow. In our experiments down below, so in these images, we have a test tube with just bromothiamyl blue in it. That is our control. We have a test tube with Elodea in it, with a snail, and then with both Elodea and a snail. In this video, we can kind of see that color change that will happen when you add CO2 to bromothiamyl blue. In this video in particular, it has a student blowing into the solution. So they're adding CO2, which will cause that change into yellow. So what we're testing down here is to see how bromothiamyl blue will change, essentially, depending on the presence of Elodea and a snail. So in our two setups, we actually have our original setup being placed in sunlight for 2 days, and our setup being placed in darkness for 2 days. Okay, this is gonna, like, what's gonna come into play here, depending on if it's in sunlight or in darkness, is photosynthesis and cellular respiration. I had 3 questions for us to respond to. For my groups that saw this on Friday, these are similar to the questions that I had you go through with your breakout groups. For the groups that saw me today, these are exactly the same as the ones you discussed within your breakout groups. So the first question says, what is bromothiamyl blue an indicator for? And what will happen to BTB when that compound is present? So as I've discussed, bromothiamyl blue is going to show us when CO2, or carbon dioxide, is present. And what will happen to BTB when that compound is there, when carbon dioxide is there? Well, if you watch that short video, you'll see that color change. The student is exhaling carbon dioxide. So when carbon dioxide is present, that solution will change from blue to a yellow color. That's important to keep in mind when we're looking at our test tubes. Remember, animals like you and I, or like the snail, go through cellular respiration. A product of cellular respiration, if we think back to those chemical formulas, is carbon dioxide. So the snail is going to be exhaling carbon dioxide as it goes through cellular respiration. And the same for the plants, because remember, our plants go through cellular respiration as well. So this color change that's happening is showing us 2 things. If BTB changes to yellow, it's showing us that carbon dioxide is present. And if carbon dioxide is present, that means it's also showing us cellular respiration. Okay, something to keep in mind. So question 2 says, which gas did the snails release? Which observations support this reference? So what gas did the snails release? Well, it's carbon dioxide. Okay, and I know that because if I look at our test tubes, we have this color change for each of our test tubes where there was only a snail. This color change will only happen if carbon dioxide is present. So our snails are going through cellular respiration and they're releasing or exhaling carbon dioxide. So my specific evidence would be that test tube S3, where the solution changed to yellow. Okay, question 3 says, why are test tubes D2 and D4 a different color than test tubes S2 and S4? Okay, so we have test tubes S2, S4, D2, and D4. So why is there this difference in color? Well, this experiment was ran through the sunlight, and this one through darkness. In order to answer these, we have to really think about what is created, or what process, happens in sunlight What process happens in the dark? So if we think back to some notes that we had, photosynthesis can only happen in the presence of sunlight. Now, we also watched a short video for our photosynthesis exit ticket, where we learned that cellular respiration happens all the time, especially in both animals and plants, happens all the time. So, what's happening when a plant is in sunlight? Well, it's going through photosynthesis and a little bit of cellular respiration. But if it's going through photosynthesis, then it's actually using up the CO2 that's being created through cellular respiration. Okay, so in the sunlight, we have S2 and S4 as remaining blue because any carbon dioxide that's being created through cellular respiration is being taken into the plant for photosynthesis. Okay, so we actually have the creation then of oxygen within these test tubes, which is why we have those little bubbles. So it's using up the CO2 and creating that product of photosynthesis of oxygen. So why is that not happening in D2 and D4? Why don't we have the same results? Well, that's because this experiment ran through the dark. Without sunlight, these plants cannot go through photosynthesis. Instead, they can only go through cellular respiration, which means they're using up any oxygen that happens to be in this test tube and are producing CO2, carbon dioxide. Okay, so with the presence of carbon dioxide, we have our BTB solution changing to yellow. So these plants are using up any oxygen that's in here and actually expelling carbon dioxide. And that's why we have this little snail up here who's going all the way to the top, because it's trying to find oxygen. It's running out of oxygen. Now it's in a liquid, unfortunately, full of carbon dioxide, which it cannot use for cellular respiration. It needs oxygen. So that leads us to our last question here. It says, what is the relationship between the snails and Alodia? Based on the results of this experiment and your understanding of photosynthesis and cellular respiration, explain why aquatic plants, like Alodia, need to be added to a snail aquarium. Use evidence from the experiment to support your answer. So this is what's going to be graded for this 3A summative. Let me know if you guys have any questions. I do want to express that you really need to explain. Make sure you hit photosynthesis and cellular respiration in regards to the snail and Alodias, that relationship. And use evidence. Look at these test tubes. Give me evidence from this experiment as to why Alodia needs to be added. Okay, let me know if you guys have any questions. Best of luck!